Good morning. Today we're going to talk about metric volume and metric mass. So these two we don't talk about as many of the different units within like we did with length, and they're very similar. And so we're going to talk about them both in one day today, and then tomorrow we're going to practice making conversions. But they are similar, and we're also going to talk about how the metric units are all related. So volume is related to mass, which is related to length. And we're going to talk a little bit about how they are linked, which is pretty cool. Um, so we're going to start with volume. And of course, volume is how much space is taken up. And when we were talking about customary, we also use the word capacity. And capacity is how much space, how much like a cup or a swimming pool or a jug, how much can actually fit inside. So that is the capacity of an item. Volume is a unit of liquid and how much space that takes up. So it's similar, it's related, but it's a little different. And we often use them kind of interchangeably, but just know the difference. And so with metric, we focus on the liquid and how much space is actually taken up. So there's 3 units that we're going to talk about, and actually this one over here that I'm covering up is hardly used at all. And so we really focus on the milliliters and the liters. And the liters are the main unit. And what's interesting about liters is that the abbreviation is a capital L. And usually you don't see too many capital letters in abbreviations, but liters are one of the exceptions. And so even when you pair it with like milliliters, you might have a small m and a capital L. Kiloliters, small k, capital L. So that's just something to make note of. If you do it differently, that's fine for now, but just something to keep an eye on, and just recognize it. You'll see it anytime you see it in a book or on a label. It will be a capital L for liter. All right, so liters are the main units. And I want us to think about like a gallon jug for a moment. So gallon jugs are a pretty decent amount of liquid. So a liter would most relate to the gallon jug, but about 4 of those liters would fit inside of a gallon. So when you think of a liter, I want you to think of maybe one of the larger water bottles, like a hydro flask, or one of the larger ones, not the one that I carried around. That one was a little bit less, but some of the larger hydro flasks that have like the jar type lid, those would carry probably about a liter's worth. Also, when you think of the larger soda bottles, they are 2 liters. So sometimes you see a smaller version of that, and it might have water in it, but that's about 1 liter. So I'm going to do the best I can. Sorry about that. So a liter is almost the same as a quart too, because 4 quarts go into a gallon. We have about 4 liters that go into a gallon. So they're very close together. So it's almost the same as a quart. And so we would say this is 1 liter. All right, so the next unit that we use more often is for something smaller than a liter, because this is a decent amount of liquid. And so when you're drinking a cup of coffee or some water from a water bottle, most of those are going to be measured in milliliters, because most of those are going to be less than 1 liter. A milliliter is actually a pretty small amount. I have a little visual here. So we recognize these from school, the little unit cubes. If this was a container, like a tiny little container, and it was full of water, that would be 1 milliliter. Okay, so that kind of gives you an idea. So if you had a dropper, like a little dropper of water, about 10 drops would probably fit in here. So it's about 10 drops of water. Okay, so I'm going to draw my little cube here. Um, we're going to say that's 1 centimeter by 1 centimeter by 1 centimeter. And so that would be 1 centimeter cubed. So 1 centimeter cubed would be the same as 1 milliliter. Okay. And when we think of measuring, I'm going to draw a little dropper here. Sorry, it's not the best, but hey. And we'll say that's about 10 drops worth. That might be about a milliliter. And also small amounts, like when you're taking medicine, maybe you have a cold or you have a cough and you're taking some cough syrup, that might also be measured in milliliters as well. Okay. So it's a pretty small amount. And so I would say most things that you drink, like a can of soda, or well, maybe not soda, maybe like a can of water, it's going to be about maybe 150 milliliters or so, maybe 200. Okay. The next one, so the other thing is, so how many milliliters do you think fit inside of a liter? Okay, I want you to think for a moment when we learned about millimeters and meters, milli meant 1,000th of, right? So 1,000th. So that means that 1,000 milliliters equals 1 liter. Okay, pretty easy to remember that one. And then kiloliter is a bigger unit. We don't use it very often because we'll just, think of things in liters because it's a larger unit as it is. This might be something like the amount of water in swimming pools or in lakes or ponds or the ocean. You would think of kiloliters. And so just like we thought of centimeter here, I want you to think of a big, giant box. Giant meaning 1 meter by 1 meter by 1 meter. And if you need help thinking about what a meter is, think about a yardstick. It's a little bit longer than a yardstick. So if we were to fill that box that was 1 meter by 1 meter by 1 meter with water, that would be the same as a kiloliter. Okay, so it's a large amount. So we might use swimming pools to think about this amount of water, or lakes. Okay, so it's not used super frequently, but I felt like it would be helpful for us to know. Also, so kilo, remember like a kilometer, how many meters were in a kilometer? 1,000. So how many liters are in a kiloliter? Also 1,000. So 1,000 liters is the same as 1 kiloliter. Okay. So next I'm going to scoot down and we're going to talk about mass. So what's interesting about mass is that it's related to weight, but technically it's different. So we think of weight as how heavy something is, which is true. It's the gravity, the way gravity pulls on us and how gravity pulls us down. So mass, so scientists needed a way to measure something on the moon, because if you go to the moon, it has different gravity. It's got less gravity than the Earth. And so things would weigh differently on the moon. If you went to any other planet, it'd be the same way. It has different mass. It's larger, it's smaller. And so it has different gravity. And so we would weigh differently. Anything would. And so scientists had to figure out something that was similar yet different. And when all I don't know the exact process. That might be a good research project for somebody to figure out exactly how they discovered how to calculate mass. But I do know it has to do with atomic structures and about atoms. And basically mass is how many atoms are in an object. And so that doesn't change. If I go out into space, think about it. You go out into space and you weigh whatever you weigh on Earth, and you go out into space, then you're weightless. And so, but but you are the same size you are the same shape of you take up just as much space. So we have to think of something that we can still measure in space or on another planet. And so mass is that unit. And so even though we think of it as being how heavy something is, and that's totally fine to wrap your brain around what mass is, because essentially that's what it is. Just know that it's slightly different. It's actually how much stuff is in an object. And so we use gravity to find mass. Like we use scales and whatnot, and that uses gravity. But there are other more scientific ways that I won't go into where they can actually find the scientific mass of an object. Won't go into all that, but just know that it's technically different. And so if we use it interchangeably with how heavy something is, that's fine. You get the idea. We all get the idea of what mass is and what weight is. But as you get higher in your science career, you're going to find that it's a little different. So anyway, I just wanted to point that out. So grams and kilograms are going to be the most important thing we're going to talk about here. Milligrams are also important, but we're going to talk about how they're a little bit different. Just like I covered up that other side with volume, we're going to mainly focus on grams and kilograms for this one. But it's good to know this too. So a gram is actually pretty small when you think about it. All right, so I have this little square, and you may remember when we were finding the mass of an object when we were measuring in class, we would use these little cubes and we would count them, and that would tell us how many grams an object of mass an object had. And so this is 1 gram. Okay, so it's not real heavy. It's real easy to carry, right? It's real easy to lose because it's so small. So there's one thing I also want to mention. Okay, come on. Focus. Okay, there we go. So if I measure this, it is 1 centimeter by 1 centimeter by 1 centimeter. Okay, that's going to be important to us a little bit later. So it's exactly 1 centimeter cubed, right? 1 cube centimeter, 1 square, not square, but cubed. So I'm going to go ahead and draw our little unit. This is what we use as a unit in math. By 1 cm by 1 cm. So 1 cm, 1 cubed unit. And that's 1 gram. And something that's a little more everyday, because, you know, we don't necessarily keep a pocket of these, is one of the larger paper clips. You may have seen me use in class. Let's see if I can find one real fast. Here we go. This is about 1 gram. To give you an idea, it's about the same. It might be just a tiny bit more or less, but it's about the same. What else? Oh, about $1 bill. If you were to take $1 bill and measure it, it would also be, well, technically any denomination of bill should be about 1 gram, whether it's a 20 or a $1 or $5 bill, it's going to be about 1 gram. So a gram is not a huge amount. So when we have a kilogram is, we're going to use that same prefix that we've seen before with kilometer and kiloliter. And so that means 1,000 of. And so imagine 1,000 paper clips. It's not going to be super duper heavy, but it's going to be a lot heavier than 1. And so 1,000 grams, let me go ahead and write that. So it would be 1 kilogram. And I want us to think about a baseball bat. So a baseball bat, that's about 1 kilogram. I'm thinking of like a wooden baseball bat. Another example might be if we had your math book and your science book stacked up, those together would also be about 1 kilogram. So it's a little bit heavier than like a textbook. We think of a textbook as about a pound or so. So a kilogram is about the same as 2 pounds. And so 2 textbooks would be close to a kilogram. So we'll just say 1 kg is, and I use that squiggly equal sign to show it's not exactly, but it's really close to 2 pounds. And we don't spend time going between pounds and kilograms in fourth grade. That's something you're probably going to do later on in your school career. But this helps us know, because we kind of have an idea of what a pound is. And so by relating it to pounds, that can help our brain kind of figure things out. Okay, so if a kilogram is 1,000 grams, and we know that grams are not too big, right? Then a milligram, milli means 1,000th of, right? So it's going to be pretty small. I would say something like dust might be a milligram, like 1 milligram in mass. When we look at medicines, if you look really closely, if you look at the tablet, it might say 500 milligrams. And so the actual tablet itself might not be 500 milligrams, that it might have 500 milligrams of the active ingredient, whatever it is that helps you. So in any case, yeah, so medicines are often measured in milligrams, dust, really small things. Also, if someone's doing like some sort of science with smaller things, like microbiology, chemistry, they might also use these smaller amounts as well. So just remember that 1,000 milligrams is going to be equal to 1 gram. Okay. There's one more thing I want to mention, and it's the cool link that is between metric systems, between the units, I should say, and they're all linked. So how are all the metric units related? And this is really cool how it works. So remember this little fella, and I measured it, and it's 1 centimeter long by 1 centimeter across by 1 centimeter high. So this would be so that's like, if this was water, 1 centimeter cubed, and if this was water that was in here, and we were to put that on a balance, say I had something here that was 1 gram. So this amount of water would be the same weight as 1 gram. So it's the same as 1 gram of water. And the key is that it's water. And part of the reason why they're using water is because water is one of the most abundant things on the earth, substances on the earth. So if this was filled with water, there we go. If this was filled with water and we were to put it on a scale, the water inside would be 1 gram. So 1 cubic centimeter of water is the same as 1 gram of water, which is also equal to 1 milliliter of water. This is the same. So this amount would also be 1 milliliter of water. So I'm going to go ahead and draw a dropper. So they're all related, which makes it pretty cool. That's one thing that's really neat about the metric system, because they link their length, their weight or their mass, and their volume. Okay. So, all right, pretty cool. Hope you've enjoyed this. Hope you've learned a few things. You're going to do some assignments now that are going to help you practice this and help you recognize the units of mass and volume. Of course, reach out if you have any questions. We'll be in touch.